Hi, let us understand about resource management for pods and containers. As we all know, Kubernetes is all about orchestrating the containers. Any pod that is getting created within the Kubernetes cluster will be having n number of containers. And majorly they will be utilizing the resources like CPU and RAM. Let's assume I do have a pod that got created and it is having two containers. And we do have three nodes. And each node will be having its own resources in terms of CPU, memory, and hard disk. Now, when the pod is getting created, internally it will be using these resources, either CPU, memory, or the hard disk. The same thing happens with the other pods that are getting created within other nodes as well. Similarly, other applications will also start creating the pods in all the nodes for auto scaling, horizontal scalability, or for vertical scaling. So we need a strong resource management in terms of how much amount of resources each container should use, and a user how many number of containers they can create, and how much it can extend the resources in terms of utilizing the CPU or memory or the hard disk. For this, we can define the resource type and the limitation, how much it can request and for how much it can grow and how much amount of resources a user can create. All this can be controlled using different ways of managing the resources. The first thing we are going to learn is about requests and limit. Request and limit. Here we will be requesting the CPU and the memory as well as the storage that we call that as a ephemeral storage, that we will be discussing it later. As of now, let's concentrate on CPU and memory. So whenever a pod needs to get created, assume it's having two containers within it. I can define each container minimum how much amount of CPU and how much amount of memory it can use. That we call it as a request. That is the minimum guarantee it will get allocated from the node. Based on the request that we are defining, it will be finding the appropriate node and that particular container will get placed within it. And we will be defining another value called limit. Limit is a hard boundary beyond which this particular container cannot utilize the resources. The kernel will be regularly checking the resource utilization of each and every container. Any container utilizing the resource more than the limit, it will be terminating it. So every container by default it can have these values, or we can define the custom values, that is request and limit. Request and limit can be set both for CPU and memory. This is at the container level. The same way we can define the namespace settings utilizing resource quota and limit range. So the namespace, I can define resource quota and limit ranges. So here for each namespace we will be defining this. That means how much amount of quota allocated for that specific namespace. N number of users can utilize that namespace, or n number of applications can utilize that namespace. Within that namespace, it will be defining this is the maximum amount of CPU and the maximum amount of memory. Altogether, all the pods corresponding to that particular user or application can utilize within that specific namespace. Like this, we can have n number of namespace within the cluster. This is defined so that when n number of users or applications using the cluster, no single user can utilize the entire capacity of the cluster and make the other applications to suffer. So we will be restricting each and every namespace with a defined amount of CPU and memory. That will be done using the resource quota. The same way, we can define the limit ranges as well. That will be defining what can be the minimum and the maximum amount of resources a particular pod can request within the namespace. So this is a property, limit range is a property of a namespace, and that will be defining how a pod should get created and what should be the range within which it can request the resources within the namespace. So as a quick revision, we have to discuss a cluster will be having n number of nodes, and a cluster can have n number of namespaces. So namespace will be defining the resource quota in terms of how much amount of CPU, how much amount of memory it can utilize within the cluster. And along with that, we will be defining another property in terms of limit ranges. That is, any pod that is requested to get created within the namespace, what is the range in which it can request the resources within this specific namespace. And when we are defining a pod, we can define the CPU resources as well as the memory resources considering two factors, that is request and a limit. Request is minimum guarantee it will be allocated for that particular container within the pod, and limit is beyond which it cannot go when it is having enough resources within that particular namespace or in the node. It can extend its capacity and utilize the additional capacity during the scaling of that particular pod, but it cannot go beyond that particular limit. So if any pod breaching this limit, it will get terminated. If any pod is making a request to create beyond this particular limit range, it will not get created at all. At the same time, if they overrun the namespace resource quota, then also the pod will not get created. So the namespace, resource quota and limit range will be verified when the pods are getting created within the namespace, and the request and the limit will be used while creating the pod, and have a check on to what extent it can extend its capacity within the namespace. So by using these four factors, that is the request and the limit of resources within the pod as well as within the Kubernetes scheduler, we will be having the settings for namespace. Using resource quota and limit page, we can effectively manage the resources within the cluster as well as the pods.